Hello, welcome back to Every Problem. This is Stewart Calculus 8th edition, Chapter 1, Section 1, Problem 26. Problem 26 says a spherical balloon with radius r inches has the volume v of r equals 4/3 pi r cubed. And we can see there that function. That's just the standard volume function, 4/3 pi r cubed. It says find a function that represents the amount of air required to inflate the balloon from a radius of r inches to a radius of r plus 1 inches. Okay, so what does that mean exactly? Well, they're asking, it says find a function that represents the amount of air, right? Air measured in volume. Let me get this. There we are. Oh, man. Air measured in volume. So what that means is we're going to have to find one total volume and subtract it from a second total volume in order to find the difference, right? Because they're saying the air from some arbitrary radius r to that radius r plus 1 inch. So what we'll do is we'll actually find volume of r plus 1, and that's going to be equal to 4/3 pi, and anywhere we see an r, we're going to put in an r plus 1, right? R plus 1 cubed. Now, if we wanted to find the volume of just r, some radius r, then it would be our first formula, 4/3 pi r cubed. Now, if we want to find the amount of air between the two, all we have to do is subtract those two volumes. And so what we'll do is we'll say amount of air required equals, and we'll put some brackets here just to really keep everything nice and orderly. It will be 4/3 pi, parentheses, r plus 1 cubed minus 4/3 pi r cubed. And that's actually going to be your answer. You could expand this r plus 1 cubed, then condense everything and simplify it. I'm not going to, because the problem doesn't say to simplify it. It just says to find a function that represents the amount of air required. And so this does do the trick, and it's nice and clean that way. It's not a super long function as if we were to expand it all out. So we'll leave it at that, and that's going to be our function for the amount of air required for some arbitrary radius r.